So now we're going to talk about the formulas of ionic compounds, how we write them, how we determine what they are, so on. Okay, so remember when we first introduced ionic compounds, we showed how sodium ions and chlorine ions come together to form sodium chloride. So this is sodium chloride. Remember, anions of single elements, in this case chlorine, end in IDE. So when we write the formula for one of these, for an ionic compound, we're going to do it by using what's called a formula unit. And the formula unit is a representation of an ionic compound and its lowest ratio of sodium, or of cations to anions. And we always list the cations first. The positively charged ions are always first. So a formula unit is a representation of an ionic compound in the lowest ratio of cations to anions. Okay, so we can imagine that when sodium chloride forms, we're going to get these crystals that look like this. But when it forms, we're going to get a bunch of different crystals. It's not just going to make one gigantic crystal. A bunch of different crystals are going to form. And they're going to be different sizes. They're going to have, one may have 1,000 sodium ions and 1,000 chloride ions, while the next one may have 1,000,000 of each. Okay, so we're going to do the formulas of ionic compounds based on this ratio of cations to anions. In sodium chloride, we can see that for every one sodium ion, there's one chloride ion. So the overall formula of the formula unit is called is NaCl. One Na and one Cl. So that means in any crystal I find, for every one sodium ion, there's going to be one chloride ion. So I'd expect in a crystal there would be equal numbers of sodium ions and chloride ions. Okay, that's what's called a formula unit. NaCl, that is the formula unit of sodium chloride. It's the simplest form. It's the lowest ratio of sodium to chlorine. But that's telling me basically that in a sodium chloride crystal, there's one sodium ion and one chloride ion. Notice when we write the formula, we don't show the charges. We know it's ionic because it's made of sodium and chlorine, so I know it's ionic. But when I make the formula, when I write the formula, I don't write the charges. Okay. The other thing we can see is that sodium ions are 1 plus, chloride ions are 1 minus. So if I take one of each, they'll become something neutral. They don't become neutral, but because there's one positive and one negative, when I make that formula of one each, it's a neutral thing. So that's what we're looking for. When we write formulas for ionic compounds, it's going to be the ratio of sodium, or the ratio of cations to anions that makes it neutral. And we're going to write it in the lowest possible ratio. Okay. So what about compounds that are formed between ions that aren't simply 1 plus or 1 minus? Okay. For example, like we saw magnesium 2 plus, O2 minus, and so on. But if I make a compound out of magnesium and oxygen, the magnesium ions are going to be 2 plus, and the oxygen ions, or they're called oxide ions. Oxide ions are going to be 2 minus. So if I put one of each together, I have the same number of positive charges as I do negative charges. So that's the ratio I want, 1 to 1. So the formula for what's called magnesium oxide, the compound between magnesium ions and oxide ions or oxygen ions, is MgO. In a crystal of magnesium oxide, I would expect one magnesium ion for every one oxide ion because of the same charge. So that MgO is the formula unit of magnesium oxide. Okay. What about magnesium chloride? Well, we've seen Mg is 2 plus, and chloride is a single minus. So if I put these together, one of each, I have more positives than negatives. Right? So Mg is 2 plus, chloride is 1 minus. I have 2 positives and 1 negative, so that's not the right ratio. What if I put in another chloride? Because initially I had too many positives, or I had more positive negatives, so let's add another negative. So now I've got 2 positives from the magnesium and 2 negatives, 1 negative each from the chlorines. So I can see that when I write the formula, I'm going to want to write it as 1 magnesium and 2 chlorines. So I'm going to write it as MgCl2 with a 2 subscripted next to the right of Cl. And that subscripted 2 means that for every 1 magnesium, because there's only 1 magnesium, there's no subscript on magnesium, so it means there's 1. For every 1 magnesium, there's 2 chloride ions. Okay, so in a crystal of magnesium chloride, I'd have 1 magnesium ion for every 2 chloride ions. So if the crystal had 1,000 magnesium ions, it would have 2,000 chloride ions. Right? So all we're doing is looking to, when we write the formula, is looking to have the same number of positive charges as negative charges, and we write it in the lowest ratio, right? Because we could write Mg2Cl4, because that would give me 4 positives and 4 negatives, but Mg2Cl4 is not the lowest ratio of magnesium to chlorine, because I can divide them both by 2 and get this. So this would be the correct formula for magnesium chloride. Okay. What about for sodium oxide? Well, we saw sodium is Na plus and oxide is O2 minus, because those are the ions of sodium and oxygen. So in this case, if I put those together, I have more negative charges than positive charges. So let's add another positive charge. And to do that, we have to add another sodium ion. So if I have 2 sodium ions and 1 oxide ion, I have 2 positive charges and 2 negative charges. So that's the right ratio I want. So Na, and I would write that as Na subscript 2 O. Whatever's to the right of that element, or of the symbol, is how many of those there are. Okay? Na2O. For every 1 oxygen in these crystals, there are 2 sodium ions. Okay? What about aluminum sulfide? We don't know sulfide, but I'll tell you what it is. So aluminums are 3 plus. We saw that earlier. And sulfide, sulfur is right under oxygen, so sulfides are 2 minuses. Now, if I put those together, what happens? I have more positives than negatives, right? So let's add another sulfide. So if I put these together now, 1 aluminum and 2 sulfides, now I have more negatives than positives, right? I have 3 positive charges and 4 negative charges. So let's put another positive species in there, Al3 plus. Okay, Al is always 3 plus. You can't just write Al1 plus and make it balanced. Al is always 3 plus. So now if I put those 4 ions together, I get 6 positive charges and 4 negative charges. So that's not quite right yet. So if I take another negative charge, because I had more positives and negatives, so let's put more negatives in there. Now I've got 6 positives and 6 overall negatives. I have 2 aluminum ions for every 3 sulfide ions. So I'd write it like Al2S3. Yep. Overall, that ratio of aluminum ions to sulfide ions, there's equal amounts. So that would be the formula unit for a crystal of aluminum sulfide. For every 2 aluminum ions in the crystal, there's 3 sulfide ions. So we can figure out the formulas of ionic compounds based on the charges of the ions. Okay. So that's the end of this one. See you in the next one.